Because the water came out and then just flapping and then just like.
Yeah, the first 2 days, because I don't have school on Thursday or anything, so I kind of just did nothing, and then Friday, what did I do? Oh, I went to a friend's house that night, and then I had to go to Saddleback in the morning for a chem review, and then Saturday I had a stats test here, and then I went to Disneyland, so. And then yesterday I was relaxing because I know the stress is starting again today. Oh yeah, it's like grass. Yeah, like I can eat that shit.
Okay guys, let's keep going. So tonight we're going to talk about two topics. The first are EKGs. And then the second are cardiac action potentials. So before we get going, next week we're going to do a lab using the recording devices over here behind you, and it will be a situation where we'll record EKGs. So tonight we'll provide you a little bit of background with what you'll be doing in lab next week. What I would do is I would encourage the ladies, if you can, wear some pants where you can pull up your pants leg so we can put electrodes on the leg right on top of the tibia. And that's all that will take. We're going to put electrodes on the arms, so put electrodes right by the wrist, and then we'll have electrodes on both legs. And from that we'll be able to get EKG tracings, and we can do that on each of you. You could do it on, say, 2 members in your group, then there'll be a set of analyses that you'll have to do with that. So, in thinking about EKGs, there is an imaginary line that we're going to refer to as a baseline. And at the baseline, we're just going to say that that's 0. Anything below the baseline will be negative. Anything above the baseline will be positive. The name of this baseline, we're going to call this the isoelectric baseline. The prefix iso means what? Means same. So same electrical signal is not changing. When you take a look at an EKG, notice that there's a small upward deflection. Then the trace returns back down to the isoelectric baseline. After a relatively short period of time, there's a small downward deflection. That small downward deflection is followed by a very rapid and large upward or positive deflection, which is followed by a very rapid downward deflection. And then the trace, the electrical activity of the heart, returns back to the isoelectric baseline and stays there for a period of time. And then there's a moderate sized deflection. And then this process repeats itself over and over and over. And as I mentioned, during the course of your lifetime, you're going to have about 6 billion heartbeats. You'll have about 6 billion of these types of traces. So let's label each of these different components. This large upward downward deflection is referred to as the QRS complex. I'm going to put Q. So this first initial downward deflection is a Q wave. The positive and large deflection that follows the Q wave is known as the R wave. And if you look up here at the trace, the downward and the negative deflection is known as the S wave. And collectively, this is referred to as a QRS complex. Now, as it turns out, every QRS complex should be preceded by a P wave. And that relatively small deflection that precedes this QRS complex is the P wave. If you sit there and take a look at the board, so we've got the P wave, that then gives rise to the Q wave. What's the Q wave? It's this downward deflection. That's the Q wave, which is then followed by the R wave and then the S wave. And then the S wave returns back to the isoelectric baseline. And after a period of time, we once again see another deflection here, a positive deflection, and this is the T wave. This interval from here on over to the onset of the T wave is known as the ST segment, one of the most important parts of the EKG. So ST segment. So we're going to create one of my favorite little tables. And we're going to go along and we're going to talk about the electrical activity. Now remember, these are electrodes that you're putting on the body. So they're picking up the electrical activity of the heart. So the P wave. The P wave represents the depolarization of the atrium. Now logic 1-1, that's what we're back to. So what you've got to do is first learn these things, but after you've learned them, then the logic hopefully becomes very apparent. So we're measuring the electrical activity of muscles. So what are the different muscles of the heart? You have the atrium, and then you have the ventricles. And which of those is larger, the atrium or the ventricles? The ventricles. Which will produce a larger electrical signal, the atrium or the ventricles?
Ventricles.
The ventricles. The QRS complex represents what?
The ventricles.
That represents the depolarization of the ventricles. So come along over here. We put Q, R, S complex. And what electrical activity does that correspond to? You guys just told me it corresponds to the depolarization of the ventricles. And this elegant remark,
Yes.
if you have depolarization, by definition, you must have.
An action potential.
Help her out here, guys. If you have depolarization, then you must also have repolarization. What part of the EKG is ventricular repolarization, Emily?
Is it the ST segment?
No, it's not.
Oh.